Copy 724, right. Center maintain 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
In this video, we're going to be covering a new section, gyroscopic flight instruments. First thing we wanted to cover is like what instruments contain the gyroscopes. So they include turn coordinator, then we got the heading indicator, and the third one is the attitude indicator, also known as the artificial horizon. It's not the altitude, it's the attitude. Indicator, it's it's also called the artificial horizon. What are the fundamental properties of gyroscope, right? So there are two fundamental properties of gyroscope. One is the rigidity in space and the other one is the precision. Space, and the second one is the precision. So a gyroscope remains in a fixed position in the plane in which it is spinning. It remains in the fixed fixed position, and the precision is the tilting or turning of a gyro in response to the deflective force, right? The reaction of this force does not occur at the point where it was applied, rather it occurs at a point that is 90 degrees later in the direction of the rotation. The rate at which the gyro precesses is inversely proportional to the speed of the rotor. So I want to correct one thing over here. It's not the precision, it's the precession, which basically means the lagging one. And that's what when I was thinking about it, it's not that precise. So the word is precession, which basically means that it's gonna lag behind the the movement. So the gyroscopes has two main fundamental properties. Is like it's not gonna tell you right away, which is the second one, precession, and the first one is the rigidity in space. Okay, what are the various power sources? And which actually are used to power the gyroscopic instruments. So again, depending on an airplane, the gyroscopes they are either vacuum, pressure, or electrically operated, right? Some airplanes have like the vacuum or pressure systems provide the power for the heading and the attitude, and whereas the electrical is going to be providing the power to the turn coordinator. But in most airplanes, like they have the two sources. They are actually using the power source and the vacuum in order to power all of them. So that will have so in this scenario they will have a redundant power source. So vacuum system. So how does it work, right? So an engine driven, so basically this vacuum is engine driven. It provides a suction which pulls air from the instrument case. So again, the normal pressure entering the case is directed against the rotor to turn the rotor at high speed. much like a water wheel or a turbine, right? So air is drawn into the instrument through a filter from the cockpit and eventually vented outside. So basically, if you have a deflection of like this, uh, like 4.5 to 5.5 inches mercury, the RPM would change from almost 8,000 to 18,000 RPM. Now we want to talk about the attitude indicator. Okay, so the gyro in the attitude indicator is mounted on the horizontal plane and depends upon the rigidity in space for its operation. So the horizon bar represents the true horizon, whereas this bar is fixed to the gyro and remains in a horizontal plane as the plane is pitched or banked, indicating the attitude of the airplane and compared to that true horizon. Limitations of this, like the attitude indicator. So a couple of things you need to remember, that the limits are in the banking and the pitch. So the banking is like, it's gonna be accurate if you are from 100 degrees to 110 degrees, and the pitch limits are like 60 to 70 degrees depending on the plane, right? So that's how much it's gonna uh, again, if the limits have been crossed and you are banking too much or you are pitching too much, the older ones, the attitude indicators would actually tumble, and you have to reset them. So what errors can be there for, again, the attitude indicators? So attitude indicators are free from most errors, but depending upon the speed, like with which the erection system functions, there may be the slight nose up indication during a rapid acceleration, or if you are actually doing a rapid deceleration, there would be a nose down indication. Whereas, like, so there's also a possibility of a small bank angle, right? So again, it happens only in the acceleration and deceleration. So how does this heading indicator operate? The operation of the heading indicator, it uses the principle of rigidity in space. The rotor turns in a vertical plane, and the compass card is fixed to the rotor. Since the rotor remains rigid in space, the points on the card hold the same position in space relative to the vertical plane. So as the instrument case and the airplane revolve around the vertical axis, the card provides clear and accurate heading information. And limitations. So basically the limitations are like, on some heading indicators found in the light airplanes, the limits are approximately 55 degrees of pitch to and 55 degrees of bank, right? Uh, when basically if you go cross that limit, right, if you are banking too much or pitching too much, it's gonna again tumble and you have to reset it. Error. Like, what errors can be there in the heading indicator? Again, because of the precession, meaning lag behind, and basically this caused chiefly because of the friction, the heading indicator will creep or drift from the heading at which it is set. Okay, and so basically it's gonna eventually go, like when you set it, it will drift, and you may have to like, so basically for every hour of operation it may actually may drift as much as 15 degrees. So you have to recalibrate it. Now the last thing is the turn coordinator. So how does it work? The turn part of the instrument uses the precession to indicate direction and approximate rate of turn. So basically the gyro reacts by trying to move in reaction to the force applied, thus moving the needle and the miniature aircraft in proportion to the rate of turn. So yeah, so basically that's why this one is used. It's able to tell you like whether the plane is slipping or skidding, or it is are you making a coordinated turns. So again, a little bit more about that. So this turn indicator, turn coordinator, like what is it used for, or what information uh, like does it provide? So the turn coordinator shows the yaw and the roll of the aircraft around the, again, the vertical axis and the horizontal axis. So the airplane will indicate direction of the turn as, like the miniature airplane plane will indicate direction of the turn as well as the rate of turn. So when aligned with the turn index, it represents a standard rate of turn of 3 degrees per second. So it has an like the inclinometer, which is a part of the turn coordinator. It indicates the coordination of ailerons and the rudders. And the last thing is like, how would this turn indicator would indicate a slip and a skid. So for the slip, again, you know that there is a tube over there and the ball is there, right? So the ball and the tube will be on the inside of the turn, not enough rate of turn for the amount of bank. Then it means it would be the slip. Whereas the skid, what will happen is like the ball in the tube will be the outside of the turn. Which basically means that you are having a too much rate of turn for the amount of the bank. The banking is less, so and the amount of turn is too much. So just remember that a perfect coordinated, in order to avoid these slips and skid turns, a perfect coordinated turn with the pressure on both the ailerons and the rudder should be applied. Thanks for watching. Those were the things I wanted to cover.